I gotta get on that thing. Yeah, push record, right.
I did.
Good idea.
Thank
Good
you.
idea.
We are live. Another thing that I just wanted to remind us of is because our test is this week, so that means that our next lesson, I'm sure we'll have a review with all those many massive amounts of questions again, just to turn our minds towards that.
That's a good point. I think I'll pick up Leah early that day.
Good. So that you can just have time, you mean?
Yeah.
Yeah, so we can spend as long as we need to, right?
Yeah, that's right.
Good.
I picked up my kid today, Ben, and our carpool line was going in different directions. And I asked him, I said, why is the carpool line going in different? Oh, we were on lockdown. I'm sorry. Why didn't let the parents know that our kids were on lockdown today?
Yeah.
They were?
I don't
What
know.
happened?
There was a burglary in the neighborhood, and I guess they didn't think to let us know or text us or anything.
All right.
Sorry.
Can we get going?
Yeah. Nova.
Yep.
I'm still trying to figure that out, but I just don't know where they got that. Anything over there. Okay.
I can't hear you.
I can't hear you.
Nothing is super loud.
Hey, Marco,
Yes?
you want to put in your earplugs? It's a little loud.
I do have earplugs on.
You do? Oh,
Maybe it's not me.
I don't know. All of a sudden, it just stopped now.
Yeah.
That was weird.
Okay, this is weird. I put www.byui.com and I got this weird thing telling me that I want to build a website, create a website. What happened here? That's not the right place. Okay.
Okay, folks, I opened up the quiz and answered the first two.
Yep, I'm there with you.
Okay. I'm going to click on SPSS so that it will open up our things in it. Actually, well, anyway, but whatever. All right. Marco, let us know when you're there.
Yeah, hold on a second because it took me to, thank you, byui.college.
Are we still going to need this applet? It says that we might, right?
Yes, but you know what? I use a different applet now.
Oh, do share.
I use, why is my thing thinking it won't let me click? Oh, because I'm starting SPSS. I use, if you just get on the Google and you Google normal applet and then you put in David Lane, it brings up an easier to use applet.
Okay. What's number 3? I think is. Can you hear me at all?
I can hear
What
you.
are we listening to? What is that sound?
I don't know. All I hear is a TV.
Hold on a second. Let me see if by any chance, I can't hear anything over here, but let me see. Hold on.
Anything on, so I can't.
Well, Ben is like way across on the other side of the house watching Sesame Street.
Estaba muy fresco.
En la clase se oía ruido, no sé si es ese.
Bájale, párale.
Hello, ladies, I'm back. Any better?
Yeah, a
Yeah.
lot more. Yeah.
My problem is that this thing is still not giving me the right. I mean, this is BYU.edu. That should work, right?
So question
Oh, there
number.
it is. Finally. I'm sorry. I'm not even there yet. I'm signing in now.
Okay. When
Oh,
there's evidence to indicate is one mean is different from the others. Question 3, I think, is false.
Let's see. In an ANOVA hypothesis test, we reject HO when there is sufficient evidence to indicate at least one mean is different from the others. That's true.
Well, I thought all means have to be equal.
No, variances have to be equal, but the means, what we're testing with an ANOVA is we're testing if all of the means are the same or if one or more are different.
Okay.
So to
That's
reject
so
HO,
confusing.
we're saying that one or more are different.
Okay. Yeah, I'm still confused about that whole thing, but I believe you.
Same here a little bit. Oh,
Yeah.
Okay, I'm finally getting into
The alternative,
this.
you have one or more of the means that are different from the others, and then the actual null is all the means are equal.
Right.
So this is true, though, because it says that indicate one mean is different from the other.
Well, if we're rejecting the null, then that means that we have sufficient evidence that one or more of those other means is different than the null. So we're rejecting the
Oh,
null.
yes. Okay. Thank you for pointing that out. Yes.
You bet. All right. Number 4. Are you caught up yet?
Okay, I am into it now. And okay, now here we are. It's opening up to number 3. In an ANOVA hypothesis test, we reject HO when there's sufficient evidence to indicate at least one mean is different.
So A and B.
A and B?
Oh, I'm sorry. You're still on question 3. I'm sorry.
Yeah, just make me look retarded here, girl.
I'm sorry. I jumped to number 4.
No, it's okay. It's okay. So, no, I have to test HO when there's sufficient evidence to indicate at least one mean is different from the others. Is that true?
It is true,
Okay.
I think. So,
Uh,
obviously, we'll
that's
see in the end, right?
That
Yeah,
seems
well,
to make sense.
You know,
to
when
me.
you pointed out that it's because it's rejected, that makes a lot more sense. I don't know why I skipped over that word. I just saw that it's not equal and just assumed. On question 4, my educated guess is A and B, but please feel free to.
Let's see. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. Sample means are all positive. Sample means don't have to be positive, but the
F distribution have to be positive.
the F distribution is always positive. Yeah.
Wait, doesn't
But
that
sample
fall under ANOVA?
ANOVA, the F distribution is always positive, but the sample means isn't always positive.
And then C is also variances are equal to each group. That's also
Yeah, so data in each group are normally distributed is true. Variances are equal in each group is true. We're assuming that they're equal. That's why we test and check them.
so it's B and C.
B and C.
Correct. Boy and cat, yeah. That's what I think.
Point of
Yeah.
That's what seems to make sense, right?
Yeah, that's why you're testing it.
Hence the answer.
Right. 5. To check if each group is normally distributed, do the following. Construct a scatter plot. Construct a histogram. Construct a QQ plot.
Okay.
Okay, now what? Because we've done, okay, we don't do scatter plot, no.
Group is normally distributed. Do the following. You would do, what do they call, column data stuff? You would do one-
Histogram.
Except, you guys, that says construct a histogram of all the data, and C says construct a QQ plot for each group. So I'm going with C because it says each group. Because we wouldn't do a histogram of all the data together.
Well, here in my notes, it says QQ plots for each of the 3 groups, or...
Okay, so QQ plots for each group.
Yes.
So that's C. Excellent.
Good job, guys. We're cruising.
6. Oh, sorry.
Oh, go ahead. I'm sorry.
Okay, we assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. No, this has nothing to do with the sample mean. The largest variance is less than 4 times the smallest variance. That's true. The largest sample mean is less than 2 times the smallest sample mean. It doesn't have anything to do with sample mean. Each group has the same sample size. Nope, so it's B.
Okay. Yes, I agree.
B as in burro.
Burro. Sí, es la verdad.
La B. Yeah, that's what we say in Spanish in school. La B de burro. Funny. Anyway, sorry. It just put me back in 2nd grade. Yeah.
All right, 7.
Anyway, deal is lost on that, but it's okay.
Oh, I'm just taking notes. Sorry.
That's okay. Okay, so
An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 6 pairs.
it says 3
1 and
pairs
2,
here.
1 and 3, 2 and 3. How many pairs are there when there are 4 samples?
Here there are 3 pairs. So when there are 4 samples, will there be 4 pairs? Because it's talking about pairs, not individual.
1 and 3, 1 and 4. Then we would do
1
2.
and 3. 1 and 3 is the one that's missing if you had 4 pairs.
2 and 3. And 2 and 4. And then all the other ones would just be the opposite. So I get 1, 2, 3, 4, 5, 6.
Let me back up a little bit. It says on here, if there are 3 samples, there are 3 pairs.
Right.
4 samples, will there be 4 pairs?
I don't
No, because there's an
have
extra
another number.
pairs.
You'd have 5 pairs.
2 sample t-tests.
You got how many, Dill?
Give me a second. And then you'd have 2 and 4, 1 and 4, and 3 and 4.
Where's
So
that
you
one?
1, 2, 3, 4, 5, 6. I got 6.
That's what I got.
Okay.
Even with 4 samples, you got 6?
Yeah, because with that extra number, you're adding 4, 2, 4, 3, 4, 1. So that's 3 more numbers.
Yeah, that makes sense. So we'll call it 6 and see what happens.
Okay.
And the
All
crowds
right,
will
now we get
rejoice.
to open a thing, you guys. Soccer shoes.
Ooh. Shall we all open the thing?
I think so.
Mine is so slow. Okay, let's see. Let's read the problem first, or the scenario. How's that?
All right.
The data in soccer shoes saved was collected to help determine how the design soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E. and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target. So smaller numbers are more accurate. Okay, well, that was interesting. So the target is hanging.
Okay. So what they're doing, they've got this target there. What they have is the kids in the shoes, and they say kick the ball, and they measure how much further they can kick the ball with the different shoes, and if one's better than the other, or
I think it's talking about accuracy and
variance. I remember.
You remember.
So go to the soccer data.
Okay, let's go to the soccer data.
And let's do, it's in alphabet, so we're going to have to transform where into numeric. So I'm going to call
it the minimum smallest variance for the 6 groups.
Right, but we have to get the printout first. For code, add new name, okay.
Mine gets so slow when I open up the SPSS. Does that happen to you ladies too?
No.
It takes a while for my SPSS to open, but my stuff opens up in it pretty quickly.
Are you even like as we do the quiz to move it up and down? Just takes longer. It's just very like in slow motion. That's weird.
Oh, whoops. Okay. All right. So here's our printout. Our stand. Okay. So what's the question again, Deal or Marco?
My
SPSS, right?
Can you read it, Deal? Because I have my screen in front of it.
I get my SPSS popped up.
Well, that's what mine. That's where mine is.
Okay. That's all right.
I got the hourglass just waiting here.
The data in the soccer save whatever was collected to help determine how the design of the soccer shoe affects the accuracy of the kick. So here's the question: what is the minimum smallest variance for the 6 groups? What is the minimum variance for the 6 groups?
Okay, so what I did is I went to Analyze and I got the printouts of the standard deviations for each group. And remember that to get variance, we square the standard deviation. So what I'm going to do...
Did you go under compare means?
Yes. And then ANOVA.
Okay, let me, there's ANOVA. Let's see, where did that, oh, there it is.
So
mine still hasn't come up yet.
Go to the smallest standard deviation, and I'm going to square that.
Okay, I'm just
5.216 is the smallest one, I think.
Okay, so we're going to move this over to the dependent list. And then what about the factor? Do we have a factor here?
Yeah, the factor is what you named when you transformed it.
Oh, I didn't transform it. I just jumped right in. Huh. Okay, transforming. Recode, auto recode.
27 point.
It's the kicking accuracy, correct?
Yes, it's accuracy. Earlier you said it was how far they could kick, but it's accuracy we're looking at.
Okay. Accuracy.
The footwear is what you have to recode.
Okay.
You have to change the A, B, C, D, E to numbers.
Okay. Footwear code. Okay. Awesome.
Does that work? Now go back to Analyze, and it should give you an option.
my thing's still halfway open. So
Gosh, Marco, that's
basically,
terrible.
yeah. So when you opened it, what did you do again, please? I'm sorry.
Okay, so Marco, when you open it, you have the data. It says footwear, and it's A, and then B, and then C and D, and then in the column next as accuracy.
Uh-huh.
Analyze things that are alphabetic. You have to turn the A, B, C, D, E to
Oh.
numbers. So you go to transform. You go to automatic
Okay.
code.
Automatic recode.
And then you're going to pull footwear over there.
Right. Okay.
And then you're going to rename it. I just put footwear code so that I know that's what I renamed.
Right.
And then, but you could say groups or brands or whatever. And then say, okay, so then that changes it to a numeric instead of A, B, C, D, F, G. And then you can go to analyze.
Now you got to analyze, and
So you go to analyze, you go compare means, you go down to ANOVA.
Oh.
Okay. Thank you.
And then you move over your accuracy into the dependent list. And you move footwear code into the factor.
And
Then I always go to options and click descriptive there.
And the footwear
Okay.
code, you moved it over to what?
Footwear goes over to factor.
A factor. Yeah, thank you.
Who wants to pull up their tests and we can just give out the numbers or the data that's needed?
The other way.
I
Oh,
have
my
it up.
goodness.
I have the
Okay.
test up.
I've
So
got a screen
standard-
that says the application is unable to communicate properly with a licensed server. Isn't that great? Thank you very much.
You know what?
After,
I would
after
really
waiting all that
fire.
time.
It's probably SPSS, and if you don't have it, it might not communicate with your computer.
Well, that's what it is, and I have it here.
I'm
but
so
anyway.
glad I spent the money and just bought it instead of using VMware because
I've been thinking of doing that. Would you
Yeah.
later let me know where I can do that?
Yeah, you just you go online, like Google it, just be like SPSS hardware, and it'll come up, and then you can buy it. I can't remember, it was like $45, and I think you get it for like 6 months.
it's $45.
$45 for like
At least it
6
was when
months.
I bought it. Yeah.
And they say you also need it for Psych 302, so I'm going to take that next semester and use it, you
Yeah,
know.
Me too.
So, oh, good. Maybe we'll be in the same class again, Marco.
I know.
Hey, yay.
Oh, are you going
I
to do it?
said
Okay.
Tanya,
Well,
you got to join us.
Psych 302?
Yeah, I'm doing it next semester. Yeah.
Yay! I think we should all plan to be in the same class.
Okay, let's plan it.
Okay.
Which class are we taking? Okay,
I don't
Yeah,
know.
we'll
We'll
talk
have
about
to look at. We have
We'll
to
worry
see.
about that later.
yeah.
Okay, so I have the test
Hey.
up. For all of the different groups, I have the standard deviation. And if we remember, to get a variance, we square the standard deviation. So it's asking for the least or smallest variance. And so I took the least or smallest standard deviation. I squared it. The number I got is 27.207.
Okay, I'm sorry, you were going a little too fast for me on that one. So what
Same
we
here.
did is we took the sum of squares, is that right?
No, they listed for us the standard deviation. And we know that a variance is that squared. Not square rooted, but squared.
I have the mean square and the sum of squares. I don't see any standard deviation on my paper.
Huh. And you did ANOVA?
I did. Hold on, let me
Oh, you didn't click descriptive. That's why.
Okay, let me see here.
Yeah.
Compare means one-way NOVA. I I have dependent as kicking accuracy and the factors footwear code. Is
Yes. Now, before you leave that little screen, click Options.
Okay, awesome.
Gives you a
And then
list. Click
descriptive.
Descriptives. Mm-hmm.
Okay, awesome.
And then that will give it to you.
Okay, now I've got a whole new screen. That's fabulous. Okay.
So you see the standard deviations for each group there, right?
All right. Yes.
Look at all those numbers. I see that 5.216 is the smallest. Do you agree?
Let's see here. Oh, I got to scroll down a little bit more. Okay. 5.216. Line C. Is that the one you just said?
Yeah, that's what I saw smallest because there's 5.230. That's bigger. So what I did is I just put that in my calculator and I squared it and I got 27.20 rounding up 7.
Okay. Let me double check your handiwork so we can get the same number and the assurance.
Hopefully, right?
All right, 5.216. Oh, jeez.
5.216.
My phone. I'm getting texts because the schools are all on lockdown right now, and so people are going crazy. And so every time I'm texting, my thing is going funny. 216 square rooted. Oh, geez.
Nope,
See?
not square rooted, squared.
Square. Okay, thank you.
That makes a difference.
I can't even push the button without getting 5 texts. I can't even see it. Okay, there it is. And you got 2.28, is that right?
No, I got 27.207.
Okay.
Rounded off, right?
Let me try it again. I was distracted with all these texts. Okay, 5.216 squared. Oh, 27.206.
Yep, rounded up is 207.
Okay.
Right?
That's, no. Yes, because the next letter is a 6. Yeah, I'm sorry.
Right. Okie doke.
Now,
Moving
just clarifying, now because they asked for the minimum, that's why we're getting the smallest number.
Correct.
Yeah, okay. I'm just making notes. Me and my notes. Darn notes.
So
Okay.
now we're going to do the largest variance.
Okay, and I'm sorry, I cleared my thing. We got 2707. Is that right?
Oh, no, sorry. 27.207.
27.207.
And that's rounded off already?
Yes, that's rounded off.
Yes.
Okay,
Right,
so I still have
now-
mine up.
Oh, the biggest one is easy because it's the only standard deviation that's in the 7s. So I will square that.
7.291.
Yep.
0.2. Look at my phone is blowing up. People, just go pick up your kid if you're not worried.
Why don't you just turn it off and you don't have to worry about it?
Well, because I'm using it as a calculator and it keeps buzzing.
But you don't have one of the other separate calculators?
I do, but that thing has driven me nuts. The first time I tried to use it in this class, it's driven me nuts. So Tana, I got 53.15, and that is not rounded up.
Correct.
Okay. Rounded up, we would do 159.
15 what?
Sorry, 53.159 rounded.
9. All right.
Yes. Sorry.
I didn't hear that 9.
Right. Folks, we are to 10. All right. The
Do we
test.
still need the SPSS up? Because I'm just keeping it
Sure.
up.
I'm going to leave mine up.
Okay, because you can just ask me the question and I can just look it up since I'm not going back and forth.
The test for equal variance.
Excuse me, ladies. Can I ask you just to recap? My whole SPSS just went away for some reason. Sorry, I'm counting on you. So number 8 was 27.207. Is that correct?
Correct.
Correct.
And number 9, was that the 53.159?
Yes.
Okay, just to make sure I was on the right page. Thank you. Now
Yeah.
we're on 10, right?
I'm actually going to go, I'm still going to go and do the SPSS deal just because I need the experience of doing
Yeah.
it. You know what I mean?
Yeah, that's me too. So that's why I was like, I'll just keep mine up and you just ask me. But no, you're totally fine. Let's get all the experience we can.
So now it wants us to do the QQ plots to see if it was normally distributed. So we go to Analyze, go to Descriptive Statistics, and then QQ plots are at the bottom.
Oh, hold on. Mine is just, there we go. Okay. Analyze, descriptives, QQ plots. And we're doing kicking or footwear. I can never remember.
We're doing accuracy.
I
Okay,
think
kicking
that we're
accuracy.
doing the kicking accuracy. That's what I'm looking at.
All right. Do I need to do I need to transform it at all, or do I just push OK?
Well, I'm waiting for my QQ plots. Where okay, here they come.
Oh yeah, mine are
Okay, so I'm looking. That's pretty normal.
that one's not.
Oh, so it does two QQ plots. It does a normal QQ and a detrended QQ. So don't look at the detrended.
Okay, just look at the normal.
So that is, yeah, it's satisfied then.
Okay.
That'll make it true, right?
Yeah.
Okay, yeah, I see here it says only the normally distributed in each group. Okay, good. I make a note of that because I like my notes.
Now, perform an ANOVA, which we actually already did.
Wait. What was 10?
What was 10?
10 was true, right?
Oh, yeah.
Okay, I'm
Because the
sorry.
variances were within 4 times each other.
Okay, that's how we found that
And
out.
11
Was true.
also true.
Our QQ plots were okay. All right, now perform an ANOVA, which we did already. Notice that the p-value is 0.018.
You mean 081?
That's what I meant.
That's what I thought you meant.
Man, I'm transposing already. All right.
You're not even 75 years old. Gee, come on, girl.
Oh, I transpose all the time.
Oh, okay. Like a 75-year-old. All right.
I
Just
know,
kidding.
right?
Just kidding.
It's pretty sad.
Just
All right,
kidding.
now we have to what?
Remove the socks.
Remove the socks data.
Everybody take your socks off.
I know,
Hey,
right?
this is Georgia, and we're enjoying like 90-degree heat, so we're in flip-flops.
Oh my
Really?
God.
We have had the
Raining
hottest.
outside, and we have a high of 54 today.
We had the hottest Halloween last night.
Wow.
We were trick-or-treating in 74-degree weather.
That's perfect.
Yeah,
Yeah,
it
we're
wasn't bad, but now we're like cooking outside today.
in
and
Southern
we're-
California here, and we're cloudy and overcast and with threatening of rain. Can you believe it?
Well, we're in a
Yeah.
drought. Last
Really?
year,
So
Last
we,
for 7 months straight, I think we had 4 days out of the 7 months that we got sunshine. But 7 months straight last year, we were completely underwater. I mean, my sister-in-law's weddings, we were getting 6 inches of rain in an hour. It was nuts. And now this year, exactly a year later, we are completely in a drought.
we've been in the drought for about 8 years here.
Oh my gosh.
Say, Our drought's been going on for a while.
Yeah.
Well, y'all are the
All
desert.
right.
Maybe we
I
can
know.
figure it out with ANOVA and SPSS.
Okay, yes.
All right. So I just
I-
took out the socks. So I'm going to ANOVA again.
All right.
Remove the
we
socks
go to,
data from the text again. What is the p-value when we remove the socks data?
Yeah. So I'm looking now.
if we're removing, don't we transform first?
No, they're already transformed. So I just took out the socks down because when I go to close it, it'll ask me if I want to save the changes, and I'll just say no.
Oh, okay. That's a good idea. Let me do that then. No.
Remember to go over to your row where you put it in numerical and take out all the sixes too.
Take out the 666.
Yeah.
Oh boy. So we're gonna take out 2s, 3s, and 4s.
No. Just the socks.
Just the socks. Yeah, sorry.
So just the
that-
6.
Is that the 6s?
Yeah.
I
just
am not.
highlighted them and deleted.
Yeah.
Oh, yeah. Okay.
Whoops, that's a 5.
So, what is the
All right, now we're
p-value
gonna go
when we remove the socks data?
Yeah. So I went back to analyze then, and I did the ANOVA, and I got 0.309.
Did you take out the footwear code and one-way ANOVA?
No, I just left all that there.
Okay, great. All right, I've got this up. I'm just making more notes because I like notes.
So by taking the socks off, we got 0.9 you said, right?
Yeah.
And so
That is the printout I got now.
the moral of the story is don't take your socks off. Okay.
I don't see much of a difference with them taking their socks off.
Well, it's more enjoyable.
The standard deviation, and I don't see much.
Oh no, go down under that's in
Oh.
the descriptive part. So there's ANOVA, go under that.
Oh, okay. I see sum of squares, mean of squares, redone.
Then the F statistic and then SIG, which is your p-value. 0.309.
And because it's more than the 0.05, we can reject that one.
Well, we haven't, I don't know. Let's see first. All right, so 13, the test statistic for an ANOVA hypothesis test is an F statistic.
1.21. Oh, sorry.
Okay. Is the p-value the area to the right or left of S statistic?
It's to the right because it's
It's
positive.
always to the right because it's right skewed. Yep. And to the left is negative, and you remember that the rule for an F statistic is that it is never negative. So it's always to the right.
What is negative? Blah, blah. Sorry.
An
What
F
is
statistic is never negative.
The F stick.
Yeah.
Yeah, I thought it said fantastic. It's F statistic.
Okay, so I'm closing this down because we're going to open a new one.
All right, so 12 is the p-value, which is 0.309, right?
0.309, yeah.
All right. The test statistic, the test statistic for an ANOVA hypothesis test is the F F static. Oh my gosh. F statistic is the p-value, the area, the right, or the right. Okay.
Yep,
Just
right.
yeah. Oh my gosh, that is awful. All I can see is static, like F static. I can't even read statistic. That's awful.
I thought my fantastic sounded better.
Yeah, definitely. I was reading static. I was like, and the F static. Okay, here we go.
All right, now we have to do hot dog.
Yuck.
I know, right?
You're getting
It's
some
not
of us
gonna be
Oh,
hungry.
let's- the first question. Let's examine the calories first. This is my area of expertise. I can tell you calories and
Hot dogs. Okay, researchers analyzed 3 types of hot dogs: beef, poultry, and meat.
beef, poultry, and meat.
Yeah.
Don't even want to know.
I'm a kosher girl. Thank you.
But up to 50% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the hot dog thing. Uses data to finally answer questions. So let's examine the calories first. 2 plots of the calories for each of the 3 types of hot dogs, and compare the variances to determine if the assumptions to use on NOVA have been met. Ay, ay, ay. Okay.
All right, let's take a gander.
Let me see if the hot dog thing will work this time. The other one didn't come up. Let me see if this.
Oh, we don't have to see it yet to answer this one. Let's examine the calories first. Oh, yeah, we do. Okay. Sorry, don't listen to me.
Let's start QQ plots. Yeah.
Okay, I'm going to do a transform first because remember the type has to be numeric. Does that make sense?
You want to change it to a numeric value, right?
Yeah. So I'm doing an automatic recode, and I'm going to take type over, and I'm just going to say type code.
Let's see. So I still can't see my screen. So before you auto recode, you do a transform, right?
Yep, transform, and then automatic recode. And then I add the new name, and then I say okay.
And the new name is Susie. Okay.
Whatever you want it to be. You can
Now,
say hot dog, you can say
I
type.
do have a question that's kind of out there. So do we always
Okay.
get the name that has the little circle with the A by it?
I don't know that, but all I know is that in order to run a test, I have to change words or letters into numbers.
Okay.
So
So we're going to do calories under your variable and then type for your new name, correct? No, it won't let me.
no, you're going to do type for the new name. That's what you're going to move over.
Okay.
Because you're not doing anything with calories yet. You're just changing beef, poultry to numbers.
Perfect. Because I was like, what? It's not letting me do anything. And I just realized I'm doing something weird. I just have like one of those like brain moments where it's like stops working.
Oh, I hear that. It's when it goes,
Yeah. All right.
What do
So
they-
do we?
what do they call it? A brain fart.
Yeah,
Okay.
that's right. So do we do
Sorry.
analyze from there? And we're going to do a QQ plot. Or no, we're going to do one name Nova? Or no, he asked for a QQ plot. Okay.
We're going to do QQ plots, yeah.
Okay, good. Or type
So-
code.
Mine's still not coming up. So you go to analyze, and from there you go where?
To descriptive and down to QQ plots.
It's under
And there was
descriptive.
something with, was there something with me needing to do differences or something after I did the variable?
Come on.
I think that was the last one I did.
That was
All right.
the last one, yeah.
I've got mine pulled up. And I'm trying to.
Okay, and it's relatively normal. Although there are some that aren't.
Yeah, let's see here.
Now, before I was getting separate QQ plots for each one of my things, so I'm not understanding what I'm doing different.
Well, that's better than not understanding what I'm doing, period.
I think what it is it depends on how they put the data in here.
Can't believe it.
Yeah, it looks fairly normal. That I can see. This
You know,
I didn't do that. That's what I didn't do. Okay, I'm doing options again. I'm doing descriptive.
the SIG again is the same as it was. Oh my gosh. I still have kicking up. Okay, why do I have both? I have beef, meat, and poultry.
That's why I always close it out because it gets me confused.
What the heck? I thought I did. But it says under my thing the type code that I just put in. Oh my gosh. I quit.
Okay, I quit this one too. Mine finally came, my hot dog thing finally came up and it was totally blank. And then a few seconds later it comes up again that the server I'm trying to use is down.
Oh, I hate
I think that's why I'm going to have to buy my own, for sure. For sure. So
Alright.
thank you for hanging on with me, ladies.
Okay, now
Hey.
I have it. For some reason it was having hot dogs and kiki. This is really making me
No, it's not bad for them.
I'm gonna go get a hot dog.
Yeah.
Calories first. 62 plus calories. So we're trying to find out calories for each of the three types and compare the variances to determine if the assumptions to use ANOVA have been met. So that's basically the question. Have the assumptions to use ANOVA been met? So the first one says the assumptions have been met. It's safe to assume each group comes from a normally distributed population from the QQ plots.
I have something. Why is mine coming up blank?
Mine did that too.
I don't know.
I have of sequence 1, type code, non-seasonal differencing 0, seasonal differencing 0, length of seasonal period, non-periodicity, non-applied, normal, estimated blooms, mean rank of tide values. Is anybody else seeing this?
Well, I'm not seeing anything because mine didn't work.
That is just the weirdest thing.
Each group comes from a normally distributed population. We could not assume. We do assume that the variances are equal. So far, I think A is true. The assumptions have not been met. They have been. The assumptions have not been met. Okay, so it's A, I think.
Let me close out of everything again and just,
So the assumptions have been met, right?
Yeah,
Then-
because we looked at the QQ plots and then we assume that the variances are normal, are equal, because that's always what we assume when we're doing an ANOVA. We've checked it, they didn't give us the variances, so we assume they're normal.
4 more questions.
Okay, run an ANOVA test to determine if the mean number of calories is the same for all three groups.
I can just tell you right now it's not going to be.
Hot dogs.
All right, calorie expert.
I know. I'm sorry. It's like saying there's all hot dogs are equal.
Aren't they?
No. There's better brands.
Wow, I didn't know you were such a hot dog expert. Thank you very much.
I am actually. I'm a hot dog. I'm a food expert. Get me on nutrition and I'm all over it. You know what our neighbors leave out?
What was our question?
Run an ANOVA test to determine if the mean number of calories is the same for all three types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F equals 16.074, and that P equals 0. The level of significance equal is 0.05. What conclusion can you draw? That we have sufficient evidence to claim that 3 hot dog types are different mean number of calories.
Okay, right. We have sufficient evidence to claim that at least one of the hot dog types has a different mean number, because remember, we don't know what they're saying about each of these different 3 types. We know that at least one and possibly more of the means are different. So it's D.
So we have sufficient evidence.
Yeah, we would have to learn different tests to find out which one is which.
So,
Yeah.
Marco, for Halloween, our neighbors gave out freeze-dried fruit snacks, popcorn, and my favorite was the school bags. They had little baggies with like pencils, erasers, and boxes of crayons, and little coloring books inside. That was my favorite. But that's what my neighbors give out my kids, because they know I'm like such a freak about food. Even
You're such a freak about dentists.
even though I enjoy my cherry Coke.
You enjoy what?
My cherry Coke.
Oh, you devil, you.
I know.
Okay.
Awful.
Yeah. Yeah. That was one thing, and anyway. Well, maybe you should give cherry Coke.
I can't hear
All right,
you.
guys. 16.
All right.
Now let's examine the sodium levels, construct QQ plots of sodium levels for each of the 3 types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. So they give us that information. Thank you. The smallest variance is 7,180.75, and the largest is 10,492.871. Have the assumptions been met to use ANOVA? So if 7 and 10, we know it's within the variances. So let's see what it says down here. It says that the distribution has a problem, but the variances are okay, because we just did that in our head.
Yes.
We did.
So let's see.
We can assume that the variances are equal.
So look at C with me. The assumptions have not been met. It is safe to assume each group comes from a normally distributed population, but we cannot assume that the variances are equal. That's not true.
I think it's either C or D. It is not safe to assume each group comes from knowledge.
Well, C says that it is not safe. They have not been met, and it is not safe.
Thank you. Thank you. So yeah. Okay. So C.
Yeah, okay. I was thinking C or D, and I was trying to figure out what's the difference between C and D, and C says we cannot assume the variances are equal, and C says we can assume that the variances are equal. Okay, perfect.
All right.
Let's hope that's right.
I hope that's right.
All right. So now the QQ plot for the poultry. Decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is the p-value for this test?
Okay, I need to go back and do the compare the means with sodium, because I have calories in there now. So I'm doing sodium. I still want descriptive. Okay. And now okay. And I get sodium output. What did it ask us for?
Let's see.
Despite the possible problem with the QQ plot for poultry, decide to use an ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is the p-value for this test?
The p-value is 0.179.
Does it show it on there, or did you figure it out?
No, it shows it on there.
0.179, and that's rounded?
Okay, well, it
Is it
just
labeled?
gives you the number, so
Oh,
it's just to those three
So what?
Question real quick.
digits.
Is that labeled p-value or is it labeled something else?
No, it's labeled SIG, S-I-G.
All right. Thank you.
What conclusion can you draw about the mean sodium levels of the 3 types of hot dogs? Use a level significance of alpha equals 0.05.
So it was greater, so we failed to reject, right?
I
What
concur.
conclusion can you draw about the mean sodium levels of the 3 types? Okay, conclusion about sodium levels. The
So
level
C.
of significance is 0.05. Okay, so sufficient
I think it's
evidence.
Right?
Oh,
It's greater.
Wait, no, it's D. We have sufficient evidence to claim that at least one of the hot dog types has a different mean sodium levels than the other type. So it's D.
Except that look what they did to us. Instead of saying we have sufficient evidence to reject, I mean, they didn't quote the A, they didn't quote the alternative, they quoted the hypothesis, the null. We do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean sodium levels.
So it's D as in dog. We have sufficient evidence to
as-
claim that
As in
at
boy.
least one of the hot dog types has different mean sodium levels than the other type. Is that correct?
No, because 0.179 is larger than 0.05, so we fail to
Zero.
reject. So we're
Yeah.
keeping, in essence, we're keeping the null.
Boy. Girl.
So we not have
Good.
sufficient evidence to reject the null.
That is so tricky. Okay, so we do not have to reject the claim that 3 hot dog types have the same mean sodiums. Okay.
Right.
That was tricky.
That was ridiculously worded and intentionally tricky, and I don't appreciate it.
All right.
Let the
I'm
record
ready,
go.
and I'll go to submit.
Okay.
You'll submit. All right.
Okay. Guys, we have 100.
Woohoo!
I know.
Isn't that wonderful?
Yay.
Wow, ladies.
Yeah, and
You're
I
amazing.
took so many good notes during this session too. Usually, like, I get it and it's clicking. This time I was like, I've got to take notes on top of my notes.
Notes on top of your notes.
Man, that kind of makes me want to have hot dogs for dinner tonight.
Hey, there you go. With lots of sodium,
I'm
huh?
gonna go get my Hebrew kosher hot dogs.
Unless I really think about it, then I don't.
Let me just take a look at that sodium again. Y'all are awesome.
My mother loved hot dogs, and sometimes I will get a hankering for a hot dog, and then as I think about it, I'm like, no.
See, and mine, I cannot have boiled hot dogs. I have to have them grilled and like basically burnt.
That's better. That's
I
better.
cannot have a boiled hot dog. It is. Ugh.
Here's how I can eat a hot dog. We call them hot dog boats. And you cut it open and you grill it and you put mashed potatoes and cheese. I can do that.
Ooh, okay. So there's something that Utah has invented. It's the J Dog that I love.
J-Dog?
It's called a J Dog, and it's out in Utah. And I had it. And I got the recipe offline. It's almost like barbecue sauce, but you grill the dog and you cut little X's into the dog, and on just the top, and then you take this sauce and you drizzle it on top of the hot dog on the bun. Oh my gosh. Like, I could eat like 5 of those suckers. So good. A friend of mine from Utah brought that over and we had hot dogs and she was like, try this. I mean, she made me a little jar of my own J-Dog sauce. It was so good.
Awesome. Well, if there's anything Utah knows how to grill, it's hot dogs. Hot dogs and burgers. That's what we call grilling.
Well, yeah, and Jell-O.
Cheap people.
Yeah, y'all are the casserole queens.
Mm-hmm.
I don't eat casseroles. I don't like Jello, and I don't like casserole.
I don't like
you,
Jell-O.
you must not be LDS.
I know, right? Okay, so I'm turning off our broadcast.
Sounds
Thank you.